Hello, and welcome to the next workshop in the series on TrueLoad. This is going to be going over a cantilever beam and beam theory and using a cantilever beam with TrueLoad. So let's get right into the theory. If we were going to take a cantilever beam and turn this cantilever beam such that it would be sensitive to two load cases, a bending load case and an axial load case, where would you place strain gauges? And let's just say that I'm going to constrain the problem to only working on the top surface of the beam. So I'm not going to let you lay it on the sides or the bottom, only the top surface of the beam. So the answer is here. So one gauge close to the wall, one gauge close to the free end. So this is where you would lay the strain gauges in TrueLoad. In theory, the theory for cantilever beam says to lay them in these two locations, and the reason is that when you look at the strain patterns, the bending load case has got a gradient, and the axial load case has got a constant value. So by doing this, you've basically got two unique strain signatures for two unique load cases. And then if you look at a general loading case, your strain signal might look something like this, and then you can take that general loading case then and break it into so much axial plus so much bending. And this is what TrueLoad does. So if you go into TrueLoad, TrueLoad will tell you to lay strain gauges at the right theoretical position. So let's go in and do that for real in TrueLoad. So like in the previous workshops, we're going to go right into the workshop folder, and then in the example files folder, we're going to go into the static beam folder, and I've got an Ansys Workbench project set up already. So we'll just double click on the Ansys Workbench project, and it's going to launch Ansys Workbench. Okay, so you can see that we've got our Workbench project loaded, and if we just go into the model real quick, I can show you what we've got. So here's our Workbench model. So you can see it's just cantilever beam. And if we come down to the analysis, you can see I've got a fixed support on the end, and I've got remote loads out here on the free end. And if we take a look at our remote loads, our remote force here, you can see what I've done is I've put on a load in the Y. So a load in the Y is 10 pounds in the Y. And then I've got a 10-pound load in the Z. And I've made this a positive 10-pound Z load. In general, with TrueLoad, I like to just keep my loads in the positive system, just because then I can easily interpret the functions I get out of TrueLoad. You don't have to. You can put them in whatever positive or negative you want, but this is what I like to do. So I've got a two-step analysis set up with a 10-pound load in Y and a 10-pound load in Z. Okay, so that's the analysis, how I've got it set up. And this model here is actually a solid mesh. And just to let you know that I've put in a named selection in here. So I've got this named selection called shell face on the top, and I've got a command object put into the tree that's basically going to set up an eSurf on the shell face. Okay, so I've done that because TrueLoad requires shell or membrane elements to place strain gauges on. We need 2D elements to place strain gauges on. So this little command object will just do an eSurf on the element faces to give you the 2D elements on the top. Okay, and then if we take a look at the results here, then we can take a look at the stress. So this is the load case 1, the bending stress here, right? And then if I go and get load case number 2, retrieve results, that's the axial. Okay, so it makes perfect sense. All right, so you've got an axial load case there. Yeah. I don't know what's going on with that. So that makes perfect sense there. Okay, all right, so out of mechanical. All right, so now we want to go into pretest. So let's go into pretest and drop pretest on our solution. And then again, we just go into an update and then double click. All right, so we're in the TrueLoad environment here. I'm going to come up here and just give us an isometric view so we can see our part nicely. All right, and our file's been automatically named pretest1 because that's the state that we're in the Workbench. But you could rename that and call that whatever you'd like. And the first thing we need to do is load in all of our unit load cases. Okay, so this button right here just loads them all in. We could load them in one by one if we want, but I just very easily just click the single load them all in. And then just to verify that we've actually got what we think it is, I'm going to just come over here. I'm going to just put this to the side a little bit more and just try to get us some room here so we can see what's going on. Okay. Normally I work with 2 strings and move these all off into 2 screens. So I'm just going to animate. So this button here in the session tools area here on the main pretest form will let us animate the strains. So the load table row is 1 is our first load case. Okay, so this is our bending load case. Okay, that makes sense. I'm going to go to undeformed. I'm going to go to the second load in our load table. And now that's our axial load case. All right, so we know we've got the results in. That looks all great. And now I just need to select gauges. So I'm going to look at this part straight on here. I'm sorry, we just need to select elements. First thing I'm going to do is I'm going to select elements. And so what I'm going to do is I click the select elements button here, and then I'm pressing the shift key down, and I'm going to click and drag and just grab everything. Okay, so that grabs all those shell elements on the top. Okay, and actually I want to get a little different selection of elements here, so I'm going to try to get the right view here that I want to look at here. I believe that's it. Okay, and so what I'm going to do now is I'm going to deselect elements. So I'm going to deselect elements except for the middle. So I'm going to come here to my element selection. And I'm looking at the wrong side. So I need to look at the other side. All right. So we're gonna deselect these elements. So I'm just gonna come here, and then now I'm pressing the Control key down and clicking and dragging, and I'm gonna click. So that got the first row of elements. I need to get the next row of elements out. Okay, that's good. And then I'm going to Control click on the other side and see if I can get those other two. So now I've got the middle strip of elements. And then because FEA models have end effects in them, I'm going to take off the last 3 rows of elements on each end. And that's what I've got. Okay. So I can highlight my selection here. So there's my selected elements. I'm happy with that. I'll go back to an isometric view. Okay. So there's my elements I've got selected for true load. I've got my unit loads here, and I'm just going to save what we've got right now. So I'm just going to click save. And now we're just going to tell true load to go find me 2 strain gauges, and we're going to click the find gauge location. So we're just going to click find, and then true load has gone out and calculated the optimal strain gauge locations, and that corresponds exactly with where our theory says it should be. Close to the fixed end, close to the free end, and that's what we've got. Okay? So that's the first part of finding gauges. So we're going to just leave that right there, and we're just going to save our TLD file and be right there. Okay? Now we're just going to exit the Wolfstar environment. Okay, so there we went on and just calculated strain gauge locations, and we're all set to go. Okay, so we're going to do something here, and we're going to generate a quasi-static event on our own on this cantilever beam case, and we're going to use that quasi-static event to generate simulated strain gauges at these strain gauge locations we just set up. And then we're going to see how well we can reconstruct our original loading. Okay, so that's the rest of this exercise. So we're going to start this off with True-QSE. So I'm going to go into True-QSE, and I'm going to just drag that onto my solution here. And we're going to get a new QSE event, and then I'm just going to say update, and then I'm going to double click that guy, and here we are. So here's our True-QSE event. So here's our model. And True-QSE is going to basically take loading functions and attach them to unit load cases. But right now we don't have any loading functions. So what we're going to do is we're going to come over here, and we are going to we're going to create loading functions here in TFU Manager. So I'm going to click on this, and it's going to launch TFU Manager, and I'm going to put our QSE window down a little bit, and I'm going to come in TFU Manager now. I'm going to generate some functions. I'm going to add a function. So I'm going to call this first one sine 01. And I'm going to have it go from a frequency of 1 Hertz to 10 Hertz. The first starting amplitude is going to be 1, ending amplitude is going to be 2. Preview. I like that. I'm going to save that one. And then I'm going to generate, let's make a sawtooth function. And I'm going to have that start at a frequency. I'll go from frequency of 10 down to a frequency of 1. And I'll have that start at an amplitude of 0.5 to an amplitude of 0.25. How about that? Okay. I don't like the shape of that. I don't like the little bit in there. Let's see what we do if we change it to do. There. I like that. Okay, so from 10 Hertz to 5 Hertz, starting at 0.5 up to 0.25, and I'm going to save, this one, and this one I got to call it, I'm going to call that saw. Okay, I'm going to save that. Okay. Now we can plot these functions. There they are. Okay, there's our 2 loading functions. Okay, and I'm just going to close this now. And actually, I think these are actually kind of low amplitude functions here. I'm going to come in here and I'm actually going to scale these up. I'm going to scale these by a factor of 10. So I've got these 2 selected here, and I'm going to do scale and offset. I'm going to multiply them by 10 and say OK. And then if I plot them up, you see that they're going to be going from plus or minus 20. So that's good. I'm going to save that now. So now I'm going to save. I've got to save my TFU file. I'm going to save it and exit TFU Manager. And now back in QSE, I still doesn't know if I've got the functions. So I just need to do a refresh. So I'm going to refresh this. And now it sees my 2 functions. So I'm going to take load case 1, which is our bending load case, and attach that to a sine wave. And I'm going to take load case number 2, and I'm going to attach that to my saw wave and add that in. Okay? So now I've got an event. I've got load case 1 attached to a sine wave, load case 2 attached to a saw wave, and now these functions are acting simultaneously and linearly superimposing these results. Okay? So that's my QSE event. I'm going to save that real quick here. And just going to close up that window there. And then I can use the results generation section to generate some things like displacements and things. So I'm going to come in here and I'm going to select a couple of nodes. So I'm going to select a node here. So I'm just clicking, selecting the node, pressing Shift, and I'm clicking and I'm getting a few more nodes. So I just randomly selected a few nodes there and said complete. And now I can plot the Y displacements. We can see what that looks like. So there's the displacements for those 3 nodes there. Great. Let's see what the X displacements look like. Okay, there's the X displacements. And let's go see what the Z displacements look like, just for fun. Okay, there's the Z displacements. Okay. So we can do some other things. We can get all of the stress. We can look at the MESI stress at those nodes. Plot that up too. So there's the MESI stress. Okay. Or we could look at, I don't know, the strain. We can look at the maximum principal strain if we want. Or we could actually just do one better here. So I can go in here and I can say, you know what, I'm going to create a vector that goes from this point here to, I don't know, this point there. So I've got a vector. And then I can say, you know what, I want to know the strain along vector. And I'm going to generate that. Okay, so I can generate strains along a vector, and all of the results we've got in this model have got a long vector aspects to them. So they all will have an along vector component to them if you want to get an along vector result. Okay, so that's just a really brief introduction to QSE. Okay, so let's just save our QSE model and get out of QSE and close up the All-Star environment there. And now we're going to go in now and go back into pretest. Okay. So it wants to be updated, so update it. So we're going to do something in pretest here. So now that we've got these gauges on our part, right? We've got our gauges there. Now we can go in and do an event simulation here, a test event simulation. So we're going to grab our QSE file we just generated. So I'm going to browse here, and we're in the Workbench file structure here. So we've got to go up a few folders. Here's my QSE event. We're going to go grab that and go back inside of there, and there's my QSE event. So I'm going to grab that QSE event that we just made, and then I can click this button here that says simulate the strains on the gauges. So I've got these two strain gauges laid here, and I'm going to tell TrueLoad then to generate the strains on those two gauges via this this event that we just created. So this is just doing a simulated test. And there's our strain signals on our two gauges. So the gauge by the free end is lower, the gauge by the fixed end is higher. Makes perfect sense. And we're just going to save that. And one thing I wanted to show you here is that we generated these strains into a CSV file. We're going to use that in a second here. Okay. So now we're just going to go into post-test, and we're going to attach post-test to pre-test. We're going to update that, and now we're going to just open up post-test. Okay, so there's our pre-test file, and so now all we're going to do is I'm going to uncheck this auto prefix thing. I don't need to have that on. And just to show you that we've got our beam up, there it is, okay. And then we're going to go grab this CSV file, but that CSV file came from FEA, so it's not microstrain, it's strain. So I'm going to uncheck the microstrain flag. And I'm going to come in here now. And now we've got a brace for, we want to make sure we're getting a CSV file, so we're going to put our filter on CSV. And now we've got to browse for that CSV file. So we're going to go up, up, and that was in pre-test. I'm not sure which one this is. I think it's this one here. And there it is, SimTest pre-test 1. And we're going to load that in. And we can plot that up. And there's our strain data. Okay. And then we can say, we can click the magic button now and calculate the loads. So TrueLoad just did all the calculations, and it had opened up an HTML file on my other screen here, and I just need to refresh that HTML file, and let's take a look at it. So there's shortcuts here that helps us jump through the file, but this is a very simple file, so we don't need to do much. So here's our desktops that we've been looking at, and I haven't gone into this stuff in much detail. So there's our first loading function we generated. So that sure looks like the sine sweep we had. And look, that second load case, this is the axial load, that looks like the saw sweep. So it just generated that. And then these are the strain correlation plots, and these are very important. So on the left plot is a time history, and the green curves are the measured strain that we took from the data file, and the blue curves are the simulated strain using these loading functions above to pull out the strains from the FEA model and plot those on top. And then what we do also is we do a cross plot. We plot measured strain versus simulated strain, and we want this to be a perfect 45 degree. Okay, so this is FEA to FEA. It should be perfect. It's linear superposition to linear superposition. It's supposed to be perfect. And we've got a little correlation table here, and it's showing perfect because this is linear FEA to linear FEA. It should show perfect correlation. And then we've got each gauge one by one, the same plots there. And then just the overview of where the gauges are. Okay, so this is just a standard HTML report that gets generated automatically with post-test. All right, and what also got generated was a QSE file. So let's open up the QSE file and take a look at it. So we're gonna just attach a new QSE event to that post test, and we're going to update the post test and open up the QSE. And you can see here that we've got our model up, and here's our 2 unit load cases, and these are the 2 sets of strain data, the 2 sets of loading functions that were generated from the strain data. Okay, so this is showing us that we've got a nice event here that came from test. All right, and we can plot that up, and that sure looks like what we started with. And then I'm just going to do one more verification here. We're going to get out of QSE, and let's see if I can use this TFU manager. I'm just going to update this one and open that one up. And let's see if we can find our sorry, this is actually coming from the post-test event here. Okay, there's our TFU file. Okay, so there's our two loads right there, and we can plot those up if we want. Okay, so there they are. So let's bring in the loads that we started with. So I'm just going to do an import TFU file here, and so I'm going to go down here to import TFU file, and then we're going to browse for the TFU file, and we're going to go up to the QSE that we originally started with, which was this one, I hope. Yes, it is. So now we can basically plot the first 2 functions against each other and see how they are. And you can see they are line on line. We can do a little formatting here. So we'll say, okay, we'll take this first function here, and let's make it wider. Okay, and we'll take the second function, and let's put a marker on it. Okay, so they are line on line. All right, and we can do the same thing with the other ones. So let's go in here now and grab those 2 and plot those. Okay, and now again you can see that they are line on line, right? So we can grab this guy and do that. Okay, and this guy, and let's make that fat. How about that? Okay, so they're line on line. All right, so this is just showing you what we can do, and the great thing with this is that this was all done by just using some strain data here. So just by using some strain data, so just by using some strain data here, TrueLoad was able to look at these 2 strain signals and be able to determine, not only the bending that you and I would probably just do intuitively, but TrueLoad was able to pick out the saw wave that was actually the axial component. So that's very impressive. So even though this looks like it's all pure sine, TrueLoad is able to pick out the saw wave that was the axial component by doing this. So that's some of the power with TrueLoad. You get to get all the loading degrees of freedom, no matter how subtle they are. Okay, so there you go. We've got a complete true load workflow from beginning to end here, showing that we can get nice correlation and we're able to bring data in and do a post-test analysis. So thank you very much, and we'll have more workshops to come.